problem that seemed to give the most trouble in the last written assignment is the last question. So I wanted to create a video for you guys to look at if you wanted some extra explanation on the solution to that question. So we're asked to analyze the solution set for a given system here. So I went ahead and set up the augmented matrix corresponding to that system. And that part certainly doesn't seem to be the issue for most people. So now you need to row reduce this matrix. So I'm going to go ahead and slide this thing up as we focus on row reducing the augmented matrix. We already have a 1 in the upper left corner here, so I would focus on getting zeros in these positions first. And I would do that using the operations -2 row 1 plus row 2 to get a 0 in that second row. And at the same time, I'm going to, just to keep this video fairly brief, -3 times row 1 plus row 3 will give us a 0 in this position here. So the first row is going to stay the same. And I need to remind myself to space these out because that last row takes some room. Okay, so second row, we would have -2 plus 2, so that's going to be 0. -2 times this, so +4 plus -3, that'll be +1, so that's fortunate there. -2 plus 4, so that's 2. And -2 times this, so -6 plus 5, -1 here. Okay. In the third row, so remember I can write the scratch work off to the side if I want to. -3 times row 1 looks like this, so that'll be -3, +6, -3, and let's see, -3 times 3, so -9 here. Sorry for what this looks like, as always. Plus row 3, which is 3k minus 5, and I'm definitely going to run out of room. K squared plus 5, and 8. So when we add that up, if you can read it, this is k minus 5, that's the worst one. -3 plus 3, so 0. 6 plus k minus 5, so that's k plus 1 here. 6 plus, this is k minus 5, gives us +1, k plus 1. -3 plus k squared plus 5 will be k squared plus 2. And -9 plus 8, so -1 here. Okay, so the first column is the way we want it. Moving over to the second column, we want a 0 in this position. So let me move this up. The row operation to get that done would be -k plus 1 times row 2, add that to row 3. We want opposite of this number, so -1 times this number, multiplied by the 1 here. And that way when we add it here, we'll get 0. Okay, so I need to make a little room here. I want, okay, -k plus 1 times row 2. So what does that look like? -k plus 1 times 0, so that's 0. -k plus 1 times 1, so that's -k plus 1. Now -k plus 1 times 2. So that's, let's write it this way. -2 times k plus 1, because it's -k plus 1 times 2. So I'm going to go ahead and write it that way. And then we've got -k plus 1 times -1, so that'll give us +k plus 1. There. Add that to row 3. So 0 plus, let me copy row 3. Don't forget about that. k squared plus 2 and negative 1. Okay, so add those together. We get 0 plus 0, so that's 0. Okay, and I paused while I copied the first two rows down. Okay, so now row 3. We have 0 plus 0, so that's 0. We have negative k plus 1 plus positive k plus 1. So you'll have negative k plus k, that's 0, negative 1 plus 1, that's 0, so great, we get the 0 here that we wanted. Now over here, let's see, we'll have k squared, we'll have a negative 2k right here, oops, negative 2k, we'll also have negative 2 times 1, so that's negative 2 plus 2, which, okay, so that the net there is 0. So in this position here, and I never leave myself enough room, you'll have k squared minus 2k. And then in the last entry here, you have k plus 1 minus 1. So the plus 1 and the minus 1 cancel each other out, and you have just k in this entry here. So there's the echelon form for this matrix. I've written out the echelon form here, copied it down next to the problem so we can go back and remember, okay, now what was I supposed to figure out with this problem? So we've reduced the matrix. That's probably the major obstacle in this problem. Now thinking about solutions. There is no solution when your matrix looks like this. So we've got, I'm just going to ignore the first two rows because we have no variables in those first two rows. So there's really nothing we can change here by picking a specific value of k. But in the last row, so no solution, that occurs when you have a reduced form that looks like this, right? You have all zeros to the left of that vertical bar, and then you've got a non-zero number here. So that's when you get no solution. So we'll have no solution if k squared minus 2k does equal 0, but k over here does not equal 0. So going over to this equation and solving it, we can factor out a k, which maybe you guys did a long time ago. And so the solutions over here are k equals 0 or k equals 2. But we just said over here we want this entry to not be 0 here. So k equals 2 is the value that will result in this thing having no solution. Because if you think about it, you'd have 0, 0, 4 minus 4, so 0 here, and then 2 here. So your last row would amount to the equation 0 equals 2, which is inconsistent. Okay, so k equals 2 corresponds to no solution. Part B, we're asked to find a k that corresponds to infinitely many solutions. And so that would happen, I'll put that here. We have infinitely many solutions if this last row were all zeros. We would have a dependent system. So that will happen if k squared minus 2k is equal to 0, and, because we need this entry to be 0 and this entry to be 0. So, and k equals 0. Okay, well, we already know the solutions over here are 0 and 2. But the only way that both equations are satisfied is if k equals 0. So your answer to part B is k equals 0. Okay, so last part. What is the value of k so that you have exactly one solution? So a system of this form has a unique solution. I guess I'll scooch over here. If let me just designate this here. So one solution, if our matrix looked like this. So we can't change the first two rows, but if this last row had this form. And here, why not? We've got we've got the ones going down the main diagonal. So if we have a pivot in every column, in every row, that'll give us a unique solution. Now, I guess I wrote a 1 here. It doesn't really matter what this number is. If it's 17, then our next step might be 1 over 17 times row 3. So this could really be, I wrote a 1, But this has a unique solution if we have any non-zero number here. And really any number here. This number could be 0. If you have your last row like this, then that just means x3 equals 0, which that could be part of a unique solution, certainly. Okay, so one solution, if k squared minus 2k is not 0, that's all we need. This entry over here could be anything, it doesn't matter. So that's if k times k minus 2 is not 0. So if k is not 0 or 2, if k is anything other than 0 or 2, we would have a unique solution. If k equals 2, oops, it turned out we would have no solution. And if k equals 0, we have infinitely many solutions. If k is neither one of those, we have a single solution.